Imagine a metal that flows like liquid silver. It glides across a surface in gleaming droplets, mesmerizing in its movement. For thousands of years, Mercury has fascinated mankind, revered for its beauty, feared for its power, and surrounded by mystery. Ancient emperors drank it in their quest for immortality, while medieval alchemists believed it could transform base metals into gold. Even Sir Isaac Newton, one of history's greatest scientific minds, became captivated by it, experimenting endlessly and perhaps even consuming it in his search for hidden truths. Why would such a brilliant mind be drawn to a toxic metal? To understand, we must explore the strange story of Mercury, its history, its properties, its uses, and its enduring allure that made it both a symbol of enlightenment and a source of peril. Welcome to Cube Chemistry, where we will discuss all the elements of the periodic system and also do experiments. So if you like this video and want to see more, make sure to like, subscribe and hit the notification bell so you will never have to miss another episode. Also, make sure to fill in the poll in the post section of the channel for next week, as we will be doing another experimental deep dive into an element again. So this is probably one of my favorite cubes. This one contains a really strange element. It is a liquid metal at room temperature. Meet Mercury. And isn't it beautiful? It's almost like liquid chrome moving freely in the tube. Depending on what your room temperature is, one of the only liquid metals. Gallium gets close, but still solidifies at a normal room temperature of like 20 degrees. Now, since it's such a beautiful element, you're probably wondering, like I once did, can you lick it? So, in the periodic leaking table it states, please don't do that, and that seems to be pretty accurate. You technically can touch or lick mercury, but absolutely shouldn't. The shiny silver liquid may look harmless, yet it constantly releases toxic vapors, even at room temperature. If you get close enough to lick it, you're also breathing in mercury vapor, which can seriously damage your lungs, brain, and kidneys. Although a single lick might not make you instantly sick, repeated or prolonged exposure can cause tremors, memory loss, mood changes, and other signs of mercury poisoning. Swallowing it is also dangerous, as mercury can stay in the body and slowly release vapor over time. Even scientists handle mercury only in sealed containers or under special ventilation. In short, mercury may look fascinating, but it's highly toxic and should never be touched or tasted. Mercury's strange liquid form made it a subject of wonder from the earliest times. Archaeologists have found mercury in Egyptian tombs dating back to around 1500 BC, indicating that ancient Egyptians were familiar with the element. In those times, mercury was often known as quicksilver, literally living silver, because it flows and splits into glistening beads, almost as if it were alive. This nearly magical behavior gave mercury a special place in various cultures. In ancient China and Tibet, mercury was believed to have healthful and mystical properties. Practitioners of traditional medicine included mercury in remedies, thinking it could prolong life and heal fractures. We now know that this was dangerously misguided. Mercury is actually highly toxic, but at the time its shimmering beauty and rarity made it seem otherworldly and powerful. One famous case is that of Qin Shi Huang, the first emperor of a unified China. Obsessed with finding an elixir of immortality, he ingested pills and potions containing mercury. Ironically, this elixir is believed to have caused his death around 210 BC. According to historical records, the emperor's alchemist had prepared a drink mixing liquid mercury and powdered jade, promising eternal life. Instead, the toxic mercury likely led to his early demise. To this day, legends say that his massive tomb is surrounded by rivers of flowing mercury, symbolizing the rivers of his empire. Modern tests of the soil near his unopened burial chamber do show unusually high mercury levels, lending some truth to the legend of mercury rivers inside his tomb. Mercury also appeared in other ancient civilizations. Ancient Hindu texts in India mention mercury in various recipes for longevity. In Mesoamerica, archaeologists have discovered pools of mercury beneath Mayan ruins, and in a temple tomb at Teotihuacan in modern Mexico dating nearly 1800 years ago. The mercury may have been placed there for ceremonial or symbolic purposes, perhaps to represent water or to amaze onlookers with its mirror-like surface. These findings show that even without modern science, people across the world found mercury captivating and gave it ritual significance. The ancient Egyptians and Romans made practical use of mercury's compounds. They mined mercury ore, a red mineral called cinnabar, to produce a brilliant red pigment known as vermilion. Egyptian and Roman artisans used this vivid red mercury-based paint in cosmetics and decorating murals and statues. Women in ancient Rome, for instance, used cinnabar rouge despite its toxicity, simply because it gave a desirable red tint. Mercury was literally adding color to their lives, though at a hidden cost to health. The ancient Greeks were also aware of mercury. The philosopher Aristotle referred to it as hydor argyros, meaning water silver, highlighting its liquid form and silvery shine. One Greek myth even involves mercury's curious properties. The inventor Daedalus in mythology was said to use quicksilver, liquid mercury, inside a wooden statue to make it move and speak. In reality, if mercury is enclosed and shifts, it can alter a statue's center of gravity or create sounds, perhaps giving the illusion of motion or a voice. A clever trick that might have seemed like life being instilled into a statue. This is an early example of how mercury's peculiar physics captured the imagination. Around 500 BC, ancient craftsmen had discovered that mercury could form alloys with other metals. Mercury readily amalgamates, mixes with gold, silver, and tin, among others. These mercury alloys are called amalgams. Early dental practitioners in China may have used silver mercury amalgam to fill teeth as far back as 200 BC, and gilders used mercury amalgams to apply gold coatings to objects. In the Greek world, artisans used mercury to extract gold from crushed ore, an ancient precursor of a technique still used by some miners today. Mercury's name has an interesting origin that reflects both its appearance and ancient beliefs. For much of history, English speakers called the metal quicksilver, and many other languages had similar terms. For example, German, Quecksilber, also means living silver. This name captures mercury's liquid, lively behavior and shiny color. The element's chemical symbol, Hg, comes from its Latin name hydrargyrum, which in turn comes from Greek hydrargyros. These old names literally mean water silver, hydra for water, argyros for silver. The same idea as quicksilver. So both in Greek and in early English usage, people named this metal for being like liquid silver. So how did we end up calling it Mercury? The name Mercury is borrowed from Roman mythology and astrology. In ancient astrology and alchemy, it was believed that the 7 celestial bodies, the sun, moon, and 5 visible planets, had connections with 7 known metals. Gold was associated with the sun, silver with the moon, copper with Venus, iron with Mars, tin with Jupiter, lead with Saturn. And the planet Mercury, the swiftest planet, was linked to the only metal that flows swiftly, mercury. The Roman god Mercury was the fleet-footed messenger of the gods, noted for his speed and mobility. Alchemists saw an analogy between the quick-moving planet and the quick-moving liquid metal. They even used the same symbol to represent both the planet and the element, the stylized caduceus or winged helmet of Mercury. Over time, the metal itself came to be called mercury in alchemical circles. This name stuck, and today mercury is the common name for the element in English and many other languages. Interestingly, mercury is the only element that still carries the name of a planet/god in everyday use, a reminder of the deep influence alchemy and mythology have had on chemistry. Meanwhile, the old term hydrargyrum serves only as the element symbol, Hg, and in older scientific literature, and quicksilver is now a poetic or antiquated synonym. After antiquity, during the medieval period and into the Renaissance, alchemy became the dominant framework for understanding substances, and mercury was at the very heart of alchemy. Alchemists were part philosopher, part proto-scientist, and part mystic. They believed that all metals were formed from primitive essence, sometimes called the first matter, and many alchemists identified mercury as its fundamental substance. In their view, different metals were mercury that had been changed or adulterated by other principles. Often, sulfur was considered the other key principle. Pure gold, the noblest metal, was thought to be Mercury in its most perfect, refined form. Thus, to the alchemist, Mercury was the starting point in their quest to transmutate base metals into gold. Alchemists developed complex symbolic languages, and Mercury's symbol was central in their texts. They personified Mercury as a spirit that could traverse between solid and liquid states, just as the god Mercury moved between worlds. Mercury, the element, was even sometimes called Mercurius in their writings, blurring the line between myth and chemistry. The association with the planet Mercury also meant this element was linked to ideas of change and speed. One of the ultimate goals of alchemy was to create the Philosopher's Stone, a legendary substance that could transform base metals into gold and perhaps grant immortality. Mercury was often the key ingredient in the Philosopher's Stone recipes. Alchemists conducted endless experiments, mixing and heating mercury with other substances, hoping to see it turn into gold or produce miraculous elixirs. Of course, these attempts never succeeded in making gold, but they did lead to discoveries of new compounds and techniques. Unfortunately, they also led many alchemists to be poisoned by the toxic materials they handled, especially mercury and lead. Even Sir Isaac Newton, the 17th century scientific genius famed for physics and mathematics, was deeply involved in alchemy. Now, this may come as a surprise since Isaac Newton's name is synonymous with rational science. But in his day, the boundaries between chemistry, alchemy, and science were blurry. Newton conducted countless secret experiments in alchemy, leaving behind extensive notes, over 1 million words on alchemical subjects. In these experiments, mercury was a common ingredient. Newton and other alchemists of his era thought if they could purify or activate mercury in just the right way, creating what Newton called sulfic mercury, it might be the vital step to produce the Philosopher's Stone or discover how to transmute metals. Newton was known to heat, distill, and react mercury with other chemicals like antimony, searching for this mysterious transformative substance. Typically, Newton paid a personal price for this pursuit. He exhibited signs of mercury poisoning during the 1690s, a period when he temporarily suffered a severe nervous breakdown. He experienced insomnia, paranoia, memory problems, and wild mood swings. Historians examined Newton's private letters and behavior and noted these symptoms and wondered about their cause. Long after Newton's death, scientists tested strands of his preserved hair and found extremely high levels of mercury and some lead, far above normal. It seems likely that Newton unwittingly poisoned himself with the mercury, absorbed through years of handling chemicals. By breathing mercury vapor in a poorly ventilated lab, through skin contact, and even direct ingestion. In fact, Newton's own notes mention observing the taste, hey, he did a can you lick it, and smell of various substances, which implies he actually tasted mercury or mercury compounds as part of his experiments. At the time, the dangers of mercury were not fully understood. Newton probably had no idea that the beautiful liquid metal could ravage the mind and body. He was driven by curiosity and the alchemical hope of unlocking nature's secret. So why did the smartest man ever drink mercury? Because in Newton's quest for knowledge, to turn metal into gold or to discover fundamental truths, mercury appeared to be a magical, indispensable tool. To him, the potential rewards outweighed the unknown risks. In hindsight, of course, we know that it was a grave mistake, but Newton's genius mind fell for Mercury's mystique, just as many before him had. Newton was far from alone. Many alchemists and early chemists of that era experimented with mercury and suffered for it. Another famous example is the English scientist Sir Isaac Newton's contemporary, Robert Boyle, who also mentioned health issues potentially from working with mercury, though Boyle was more careful. In the centuries before modern chemistry, mercury's role was so central that the word mercurial came to describe something erratic or lively, much like the metal's quicksilver movement or the unpredictable moods of somebody affected by mercury exposure. Beyond alchemy, mercury found a prominent, if unfortunate, place in medicine. From ancient times through the 19th century, healers and physicians once prescribed mercury-based concoctions for a variety of ailments. A notable use was in the treatment of syphilis, a serious and common disease, especially from the Renaissance through the 19th century. From the 1500s and onwards, doctors discovered that applying mercury ointments or giving mercury compounds to syphilis patients sometimes seemed to ease the symptoms, likely because mercury is a potent chemical that can kill bacteria on contact, though it also harmed the patients. The saying "a night with Venus, a lifetime with Mercury" emerged in the 18th century, meaning a single night of pleasure, Venus, the goddess of love, symbolizing contracting syphilis, could lead to a lifetime of mercury treatments. These treatments were crude. Patients might be rubbed with mercuric ointment or given mercury salts to ingest or as vapor baths. Many patients lost their teeth, developed neurological damage, or died from mercury poison, all while trying to cure their illness. It was a brutal remedy that often was as bad as the disease. Mercury chloride, known as calomel in its mild form, and corrosive sublimate in its poisonous form, became a common medicine in the 18th century and the early 19th century. For instance, calomel was used as a laxative and dewormer. Lewis and Clark's expedition carried calomel pills. No, not that Lewis and Clark, which were so laden with mercury that archaeologists today can trace the expedition's campsites by testing the soil for mercury from their latrines. This highlights how heavily mercury was used in medicine, leaving a literal toxic trail. Folk and traditional medicine also found uses for mercury. In Ayurvedic medicine of medieval India, mercury was sometimes combined with other ingredients in tonic preparations, again under the belief it could revitalize the body. In 19th century America, some people took patent medicines that contained mercury. Even in the 20th century, teething powders for infants and some antiseptic solutions contained mercury compounds, until their dangers became apparent. Mercury's ill effect on health eventually gave rise to cultural references. The phrase "mad as a hatter" is one such legacy. In the 18th and 19th centuries, hat makers used mercury nitrate to treat animal furs in a process called kerating, because it turned fur orange to make felt for hats. Prolonged exposure to mercury vapor in poorly ventilated workshops caused hat makers to develop neurological damage. They would tremble, slur their speech, suffer memory loss and depression, and display odd personality changes, symptoms of chronic mercury poisoning. People noticed that hat makers often acted mad after a few years on the job. This led to the saying "mad as a hatter," which was later popularized by the Mad Hatter character in Lewis Carroll's Alice's Adventures in Wonderland. The connection was so direct that by the mid-20th century, mercury's use in hat making was banned. But the phrase has lived on in language, a haunting reminder of mercury's toxic power. As the world moved into the Renaissance and later the Industrial Revolution, mercury continued to play a crucial role. Now, not as an elixir or alchemy key, but as a practical industrial material. One of the biggest chapters in mercury's history was the use in precious metal mining. In 1557, a breakthrough method called the Pacio process was developed in Spanish colonial Mexico for extracting silver from ore. This process involved mixing crushed silver ore with mercury. The mercury would amalgamate with tiny silver and gold particles in the ore, separating them from the rock. Now, after mixing, the resulting mercury-silver amalgam was collected and heated, which evaporated the mercury, releasing it into the air, and left behind pure silver. This method dramatically increased silver yields and led to a mining boom. Huge quantities of mercury were required. As a result, mercury became an essential strategic resource for the Spanish Empire. The Spanish crown had long operated the Almaden mercury mine in Spain, which had been active since Roman times and was one of the richest mercury sources in the world. After the Pacio process took off, demand for mercury soared. Spain began shipping flasks of mercury from Almaden across the Atlantic to their mines in the New World. However, the Americas themselves soon provided another source. In 1563, the Spanish discovered a massive mercury deposit in Huancavelica, Peru. This site turned out to be extraordinarily rich in cinnabar ore, and it became known as the Mountain of Mercury. Together, Almadén in Spain and Huancavelica in Peru produced most of the world's mercury for the next few centuries. The two mines were often referred to as the King's Twins because silver from places like the famous Potosi mine in Bolivia and the Zacatecas in Mexico depended on mercury from those sites. It's estimated that over 100,000 tons of mercury were mined from the Peruvian mine alone in the colonial era. An astonishing figure, especially considering how much toxic exposure that entailed for the indigenous laborers and prisoners forced to work there. Mercury mining and refining in those mines was extremely dangerous. Workers were exposed to mercury vapor daily. Many died or were disabled by a combination of toxic effects and the harsh conditions. Mercury poisoning among miners and smelter workers was common, though it was not well understood medically at the time. By the 19th century, new techniques like the cyanide process began to replace mercury for gold and silver extraction. Since using cyanide could chemically dissolve gold out of the crushed ore without the need for mercury amalgamation. But mercury was still used in many places because it was simpler and the infrastructure for mercury amalgamation already existed. In the California gold rush in the 1840s and the 1850s, for example, prospectors used mercury to form an amalgam with gold dust from river sediments. California even had its own mercury mines, such as the New Almadén mine near San Jose, which was named after the great Spanish mine for its importance. Mercury from the New Almadén and other U.S. mines supplied the gold mining industry on the American West Coast. As a result, parts of California's environment still suffer from mercury contamination to this day, legacy of those gold rush days where mercury was spilled into rivers and soil. Outside of mining, mercury enabled several scientific and technological advances from the 17th through the 20th century. One of the earliest was Evangelista Torricelli's invention of the barometer in 1643. Torricelli filled a long glass tube with mercury and inverted it into a dish of mercury, creating a vacuum at the top of the tube. The mercury column sank and stabilized at a height of about 76 centimeters at sea level. That balanced the weight of the atmosphere. This was the first barometer using mercury to measure air pressure. It proved that air has a weight and pressure, a foundational experiment in physics. The measurement unit, millimeters of mercury, mmHg, for pressure, originates from this device and is still used, for example, in blood pressure readings. The mercury thermometer was another breakthrough. Daniel Gabriel Fahrenheit, a Dutch-German instrument maker, perfected a reliable mercury in glass thermometer by 1714. Mercury was ideal because it expands and contracts uniformly with temperature and remains liquid over a wide range, minus 39 degrees Celsius to 357 degrees Celsius. Fahrenheit even chose his temperature scale partly based on mercury's properties. Mercury thermometers became the standard for temperature's measurement for almost 300 years thereafter, used in medicine, cooking, science, and industry. Mercury have been known since ancient times, but it's actually quite rare in the Earth's crust. On average, the crust contains only about 0.08 parts per million of mercury, which means only 0.08 grams of mercury per ton of rocks. That's a tiny amount. However, mercury has the tendency not to spread out uniformly. Instead, over geological time, mercury can concentrate in certain minerals and locations, often associated with volcanic activity and hot springs. The primary mercury ore is cinnabar, a mineral composed of mercury and sulfur, with the chemical formula HGS. Cinnabar is easy to recognize by its distinct color. It's usually brick red to scarlet, and it was prized as the source of the pigment vermilion. Extracting mercury from cinnabar is a relatively straightforward process that has been used for centuries. The ore is first mined from the earth, historically by pickaxe and later with drills and explosives. The raw cinnabar ore, which might contain 1% or 2% of mercury by weight in rich mines or even more in high-grade areas, is then crushed and heated in a furnace. When cinnabar is roasted in air, a chemical reaction occurs. The sulfur in the cinnabar combines with the oxygen to form sulfur dioxide gas, and mercury is released as a vapor. In equation form, it looks like this. The mercury vapors are then channeled and cooled, often through a series of pipes and chambers. As the vapor cools, it condenses into liquid mercury, which can be collected. In olden times, mercury was condensed on cold walls of a chamber or even in water. Workers would then gather the liquid metal into flasks. Traditionally, mercury was shipped in iron flasks, about 76 pounds or 34.5 kilograms of mercury per flask. Iron was chosen because, interestingly, mercury does not amalgamate with iron readily. So an iron container can hold mercury without being dissolved by it. While the chemistry is simple, the process is extremely hazardous to those doing it. Imagine being a smelter worker in, say, 1800. You shovel cinnabar ore into a hot furnace and out comes not only the valuable mercury, but also clouds of toxic fumes, both mercury vapor and sulfur gases. Without modern ventilation or protective gear, those workers inhaled some of that mercury. Many suffer tremors, gum loss, mercury can cause teeth and gum deterioration, and other classic symptoms of mercury poisoning. Fast forward to the present. Modern mercury production is much lower than it was a few decades ago, because many uses of mercury has declined and some countries banned new mining. Yet mercury is still being produced mainly to meet the needs of certain industries and the demand from small-scale gold mining. In recent years, the vast majority of the world's mercury, as high as 80 to 90%, comes from China, which continues to mine mercury, often as a byproduct of other mining, and export it. A few other countries produce smaller amounts, such as Kyrgyzstan or Tajikistan in Central Asia, and countries like Mexico or Indonesia, where mercury might be recovered as a byproduct of gold mining or other metallurgical processes. By 2020, China's dominance in mercury production was very clear. It produced nearly 90% of the global output, with only a minor contribution from others. One noteworthy aspect is that a lot of mercury now comes not from primary mercury mines, but as a byproduct. For example, some gold and zinc mines have cinnabar or mercury trapped in their ore. Because of mercury's toxicity, international efforts have aimed to reduce mercury mining and use. The Minamata Convention on Mercury, a global treaty that came into effect in 2017, has over 100 countries committed to limiting mercury. It seeks to ban new mercury mines, phase out mercury in many products, and control mercury emissions. This means that over the coming years, the production and circulation of mercury should further decrease. So what makes mercury so special that people have been captivated by it? Much comes down to its physical and chemical properties, which are unlike any other metal. Let's break down some key characteristics of mercury in simple terms. Mercury is the only metal that is a liquid at ordinary room temperature, around 20 degrees Celsius or 68 degrees Fahrenheit. In fact, it's one of the only two elements in the periodic table that are liquid at room temperature. The other one is bromine, a non-metallic liquid. Mercury's melting point, the temperature at which it freezes into a solid, is minus 38.8 degrees Celsius or 37.9 degrees Fahrenheit. That's well below the freezing point of water, which is why mercury is liquid in any normal environment. If you put a bottle of mercury into a freezer, it might eventually solidify into a silvery solid chunk. Early scientists did this to study it, as in 1759 when Michael Lomonosov and Anders Celsius reportedly froze mercury to prove it could turn solid. Mercury's boiling point, where it becomes a gas, is 356.7 degrees Celsius or 674 degrees Fahrenheit. That is relatively low for a metal. For example, iron doesn't boil until over 2800 degrees Celsius, which means mercury evaporates into vapor more easily than many people realize. Even at room temperature, a tiny amount of mercury will slowly evaporate, releasing invisible toxic vapor. You might notice a faint metallic smell if a lot of mercury is exposed, but generally you can't see or smell its fumes. Mercury is also extremely dense. It's about 13.6 times heavier than water. To visualize that, 1 liter of mercury, about a quart weighs about 13.6 kilograms, 30 pounds. If you had a bucket full of mercury, it would be overwhelmingly heavy. Now, this density means that many metals and objects that sink in water will float in mercury. For instance, iron, coins, lead, and even pieces of gold or cannonballs can float on a mercury bath, like a cork on water. Gold and lead are heavy, but mercury is even heavier. There is a famous demonstration of this. A person's footstep on a tray of mercury will not sink fully. It's like trying to step on solid ground because mercury can easily support the weight due to its density. Although doing this is very dangerous because of the exposure. Mercury's density also made it useful in devices like barometers and manometers. Because it is so heavy, a relatively short column of mercury, 760 millimeters tall, balances the pressure of the entire atmosphere. If we use water instead, we need a 10-meter high tube. Mercury also has a very high surface tension, which is why it forms rounded beads so easily. If you spill mercury on a surface, it doesn't wet the surface like water would. Instead, it forms little balls that roll around. Those droplets can emerge when they touch each other, forming bigger beads. This property made mercury fun to play with. Children in the past would sometimes handle mercury, rolling droplets in their palm, not realizing the risks. The beads also readily break apart if you try to split them. This behavior is a clue to Mercury's atom structure. Mercury's atoms bind to each other fairly weakly compared to other metals, which is why it's liquid. But they are very cohesive in the sense of surface tension, meaning each atom would rather stick to its fellow mercury atoms than other surfaces. Mercury is also a good conductor of electricity, but not as good as solid metals like copper or aluminum. Still, because it's liquid, it makes smooth electrical contacts, hence its use in switches. Mercury is a poor conductor of heat, relatively to other metals. In fact, among metals, only a few, like plutonium, are worse in conducting heat. If you held a droplet of mercury in your hand, don't do this at home, it would not take away heat as quickly as, say, touching a piece of copper. This low thermal conductivity means mercury doesn't easily distribute heat within itself, which is one reason it expands evenly with temperature, making thermometer readings consistent after it equilibrates. Mercury is relatively unreactive with many common substances. For example, it doesn't react with oxygen in the air at room temperature. It can sit exposed and remain shiny, unlike something like iron, which rusts, or copper, which tarnishes. Over long periods, a thin layer of oxide might form, but it is not obvious. Mercury also doesn't react with ordinary acids like dilute hydrochloric acid. However, strong oxidizing acids will attack it. Nitric acid, for instance, dissolves mercury, producing mercuric nitrate and toxic fumes. Hot concentrated sulfuric acid will also react with mercury. Mercury readily reacts with sulfur. If you sprinkle sulfur powder on a mercury spill, it will bind and form mercury sulfide, neutralizing the mercury, a common cleanup trick. This dependency is used in mining. Mercury is sometimes added to sulfur-containing ores to draw out precious metals, but more often it's the other way around. Sulfur is used to bind mercury spills. Mercury can form chemical compounds where it usually has an oxidation state of +1 or +2. Mercury compounds, also called mercurous compounds, involve two mercury atoms paired together, acting as a single unit. It is a diatomic ion in these compounds. An example is mercury chloride, also known as calomel. Calomel is a white powder that is used as a medicine, laxative, teething powder, historically. Mercury 2 compounds, mercuric compounds, have a single H2 plus ions, and these tend to be more soluble and often more toxic. Mercury 2 chloride is a very poisonous salt, once used to disinfect wounds and also infamously as poison in mysterious novels. Mercury dioxide is a red or orange solid, and this is the substance that Joseph Priestley in 1774 used to discover oxygen gas. Mercury oxide releases oxygen when heated strongly, leaving behind liquid mercury. Now, mercury sulfide we've mentioned earlier as cinnabar in the red form and metacinnabar in the black form. It's actually relatively stable, and in fact, if mercury is spilled, turning it into sulfide is one way to lock it up because mercury sulfide does not dissolve in water easily. Now, from the chemical perspective, mercury's interaction with living tissue is what makes it so toxic. Mercury metal in liquid form is not readily absorbed through the skin, but its vapor can be inhaled and quickly enters the bloodstream and nerve system. Mercury in the body tends to bind to sulfur-containing enzymes and proteins, disrupting their function. This is why mercury poisoning affects so many systems. It can damage the brain, nerves, kidneys, and immune system. Now, some compounds of mercury, like methyl mercury, an organic mercury compound that forms when mercury is in the environment and bacteria act on it, are especially dangerous because they are absorbed easily and accumulated in the food chain. Fish can concentrate methyl mercury, for example. Even though toxicity isn't a property you'll find on a standard periodic table, we got the periodic leaking table for that, it's a crucial part of mercury's identity in practical terms. So much so that chemists have to be extremely careful when working with even a small amount of it. Now, mercury is a heavy element, atomic number 80, and it has several stable isotopes. Naturally occurring mercury is a mix of about 7 stable isotopes, like Hg202 and Hg200, etc., none of which are radioactive. There is nothing particularly unusual for the layperson about these isotopes, but one fun fact is that because mercury has such a high atomic weight, you can actually detect mercury atoms in a sample using nuclear magnetic resonance techniques in advanced chemistry labs. Hg199 and Hg209 isotopes are NMR active. Now, despite or because of its toxicity, mercury has been used in countless ways throughout history. Mercury was essential in thermometers, barometers, and blood pressure gauges for centuries due to its steady expansion and high boiling point. These devices are now digitally, though the unit mmHg still remains. Mercury vapor made fluorescent and neon lights possible and was used in switches, relays, and batteries. Modern LED lights and mercury-free batteries have replaced those uses. Mercury acted as a catalyst and electrode in processes like chlorine production and small-scale gold mining. Still common in some regions, despite severe environmental harm. Older vacuum pumps also rely on mercury, but have been since replaced. Mercury appeared in dental amalgams and antiseptics such as thiomersal in vaccines, though most medical uses are discontinued. Only a few persist in limited context. Vermilion mercuric sulfide was prized as a bright red pigment in painting and lacquerware. Safer synthetic pigments have now replaced it. Mercury fulminate revolutionized firearms by enabling reliable percussion caps. It has largely been replaced by more stable compounds. Mercury was tested as a coolant and even as a propellant in NASA's Mariner 10 mission, but was abandoned due to toxicity and corrosion. It was also briefly used in experimental power plants. Historically, mercury featured in novelty fountains and even floating beds for the wealthy, dangerously displays of extravagance. Mercury attacks the nerve system, causing tremors, memory loss, and tooth decay. Organic forms like methyl mercury accumulate in fish and can severely harm developing brains, as seen in the Minamata disaster. The case of Dr. Karen Wetterham, who died after a few drops of dimethyl mercury penetrated her glove, underscores its lethality. Because mercury doesn't degrade, it lingers in the ecosystem, contaminating rivers and entering the food chain. The Minamata Convention now regulates its use and emissions, yet illegal gold mining and fish contamination remain a global challenge. Sir Isaac Newton, perhaps the greatest scientific mind of all time, was drawn to Mercury's mystery. He spent countless hours in its presence, driven by the hope that Mercury might reveal nature's deepest secrets or literally turn lead into gold. In the end, Mercury may have brought Newton not enlightenment, but illness. Why did the smartest man ever drink mercury. Because knowledge and discovery can be intoxicating pursuits, and mercury was thought to be the key to unlocking them. Newton's brush with mercury illustrates that even the wisest among us can underestimate the dangers of the natural world. It took many years and many poisoned lives for humanity to fully grasp mercury's peril. Today, with the benefits of science, we treat mercury with great care and respect. We now know that one should never drink mercury, inhale it, or handle it carelessly, no matter how shiny or intriguing it is. We've largely removed it from the common products and curtailed its industrial release. Now, we would like to thank the members that support our channel. Thank you for doing this. We really appreciate you. Now, if you think we missed anything, tell us in the comments. And if you want to know more about another element that is liquid at almost room temperature, take a look at this video about gallium next.